start recording. Session is being recorded. Excellent. So, Soundex. The first thing to talk about with Soundex is why on earth we do it in the first place. The reason that we want to have a Soundex function is because it is useful in something like a searching algorithm to be able to say, this sounds a lot like this other thing, so it's possible that someone would have mistyped it. So maybe you misheard Taylor Swift, Taylor, as Tayler. And if you mistype that, you'd probably want the search to come up to show you both Taylor and Tayler. And the most common way of doing that is with an algorithm called the Soundex algorithm, which is what we implement. So looking first at, and I'll share my screen here, hopefully, so that we can take a look at the exercise. Share application or screen, share Firefox, don't crash, very good. Cool, so if we look at the assignment, we go down to stage 4, we go down to Soundex. I'm just gonna have to ask, if you've just joined the call, please make sure you're muted. So the whole job of this command is that you'll be able to run the Soundex search via, I believe it's the S command, I think. Is it S? Yes, S. And it will look for, awesome. It will look through the entire library and print out all of the tracks that have an artist that sounds like this argument artist here. So if I typed in Tayler, and that was the search that I was doing, then it would print out anything that ended in, or that consisted of Taylor. Any questions about that so far, or is that sort of making sense? And if you've just joined, please make sure you're muted. Okay, awesome. So people are happy with that. So let's take a look specifically at the .h file, which is the point of call for if you're looking for more information about something. Go through and print out everything that has the same Soundex encoding, print out in the order which they're stored in the library. You should preserve the order of playlists, and then you should preserve the order of tracks. And then we get the specific rules of the Soundex algorithm that we want you to use. And they're written here. So let's talk through them. We're going to start with the string that we already have. So let's say that the string is Taylor, Taylor. That's the string we already have. So we would retain the first letter, right? And let me just step back and say the whole point of this, what we want at the end, is another series of letters and numbers that represents what that first input sounds like. So for instance, Taylor encodes to T460. And that is a representation of the sound of saying Taylor. Mark encodes to M620, which is the sound of saying Mark. And so if I was to type in something else like Tayler, that would also end in the encoding T460. And the idea is, well, even if the initial words that we have are different, if the encodings are the same, then they must sound the same. That's what we want to do. So first of all, we retain the first letter. So for instance, for Taylor, the first letter is going to be T. And the idea behind this is, well, if it starts with a T, it's pretty hard to mix up one letter at the start of a word with another letter. So Taylor sounds like it starts with a T. So T is the first letter. We then map all occurrences of these letters, A, E, I, O, U, Y, H, and W, to 0. And what that means is, in your string, everywhere that there's an A or an O, map that or change that to be a 0. Then we follow these rules here to replace a bunch of other letters with corresponding numbers. So if you have a T, you replace it with a 3. If you have a N, you replace it with a 5. That's the sort of rule that we're going to follow. After that, there are some more instructions about, given that string that you've got to replace some words, you've got to compress it down a little bit, and then you've got to make sure the right number of letters and numbers in it. But at the end, you'll end up with something like M620. And that encoding will mean whatever I type in, whether I typed in M-A-R-C or M-A-R-K or M-A-R-S, they all end up sounding something like M620. And so then we would go through our playlist and we would look for every place where it sounds like M620, and we would print those out. And that's how Soundex works. Any questions? Cool. Any questions about that, or are we all good? Could I go through an example of a name and how to encode it? Sure. Let's go with Taylor, since that's the example that we've already been given. Let me pull up a text editor. I agree that they're complicated. That's a fair point. This is an example we were working on earlier. Let me just get rid of some of it, and I just want to be able to edit text in here. That's all I want. I'll get rid of this. So say that we've got the word Taylor. Step 1, retain the first letter. So the first letter is T. T. Step 2 is replace all occurrences of A, E, I, O, U, Y, H, and W to 0. So I think what that means is that A will be a 0, O will be a 0, and then this, everything else. Is a Y mapped to a 0? Y maps to a 0 as well. Okay, perfect. 0. Then we follow this other instructions. So L maps to 4 and R maps to 6. So it's 4 here and 6 here. Cool. Placed all of that. We then replace all adjacent same digits with 1 digit and remove all of the 0 digits. So we look through here and we say, well, are there any 2 digits which are the same thing? So there's no 4 next to this 4 and there's no 6 next to this 6, but these 2 zeros are together, so we could delete them. And then we also say, well, we have to get rid of all zeros. So we get rid of all zeros. Now we're left with T46. Cool. If the first digit matches the numerical encoding of the first letter, remove the digit. So the T is the first letter, and then how would we encode T? We'd encode T, T would be 3, and 3 is not equal to 4. So this would be encoded to a 3, this would be encoded to a 4, so they're different, so we don't have to follow that 5th step. This 5th step doesn't apply. And then finally, append 3 zeros if the result contains less than 3 digits. So how many digits do we have here? We have 2 digits here. So we append 3 zeros, 0, 0, 0. And finally, the very last thing we have to do is remove all except the first letter and the 3 digits after it. So 2 of those zeros go away. And that's how we end up with T460. Any questions about that process? Anything that didn't make sense there? Cool. Glad to hear it. Ready. I'll stop recording now.